Here they come. Good morning, Maddie. How you doing?
I'm good. How are you?
I'm doing great. I just ended a incredible class period with period 4 MRWC, and now I'm all fired up for you guys. I mean, we had a really good session the last hour and a half, and so I'm hoping to do it again with my period 5. Period 5, rock and roll kids. Good morning, everybody.
Good morning, Mr. Ainsworth.
All right. Thanks for actually showing me or let me hear your voice. I like it.
Hey, I sent you an email last night. And so I want you to take a look at it after class, if you could.
Sure. No problem. No problem. I will do that. Okay. We are going to, before we get into 783 here today, guys, we're going to do a little warm up to set the expectations and everything. So this is on Canvas if you want to print it out. If you don't, just get a piece of graph paper out and write this problem down. It's totally up to you. It's in the same page as 783 part 1. So just go to that page in Canvas and take a look at it if you want to do a quick print. But like I said, if you don't, use graph paper and just follow along. We'll work together here a little bit before we launch the activity. So let me get things going here. Okay. Dun, dun, dun. I hope everybody's doing well. Got the weekend rolling right around the corner. Does anybody have any big plans that you can tell me about? Any big plans coming up for the weekend? No big plans. Okay. I don't have any big plans either. Just we have a 2-year-old birthday party this weekend at my wife's family's house. The 2-year-olds are obviously 2 years old, and so we're gonna have a bunch of little rugrats running around the place, a little birthday action, barbecue action, probably. That's the only big thing going on in my life right now. All right, here we go. Let me go to Canvas here. I'll show you exactly where it is. So we're submitting our work today on 7A3. So if you open up part 7A3 part 1, activity part 1, go into that page, you'll see the warm up. So if you want to click on that link and print that off, you may. That's totally up to you. If you don't want to do that, well, then just get a piece of graph paper out and copy this problem down, and we're going to work on it here a little bit. And we're going to take the activity into 2 parts. We're going to do 1 part at a time and have a discussion and submit your work today during class. So that's the goal. Let me see. Bella's going to Watsonville. Bella, is that up north somewhere? Where's Watsonville?
Yeah, it's like by Santa Cruz.
Oh, way up there above,
Yeah.
North of San Francisco. Yeah, in the, have you been there?
Yeah, my grandparents live over there.
So is that where all the big trees are?
Yeah.
Oh man, that's gonna be fun.
Yeah, it's really pretty up there.
I can imagine. So, well, enjoy your time. That's awesome. I'd be looking forward to that too. I wouldn't mind taking a road trip. Love going in the mountains. Okay, when you're ready, type in ready, and then we'll start on this review. I mean, not review, warm up here. I'm gonna work this with you guys here and set the expectations of the activity and work with you guys here today. And my goal is to finish the activity with you guys in class today. All right, so Kaylee, Kennedy, Mason, Alexis, all you guys are. Yes.
Did I had a question. Were we gonna have a quiz today too, or was that next week?
Well, your quiz today on section 7A, 1, 2, and 3 is going to be on Monday. Today,
Okay.
So 7A3, I think, is the last No, there's 7A4 as well. There's one more activity in 7A. No, there's two more, 4 and 5. But I'm going to give you a quiz on Monday anyways over the first 3 sections. So, or the first 3 activities. Okay, so let's get started here.
Okay.
Let's do this. Here we go. Let's see what you guys have learned through my prep videos, and let's see who's on track. So first part of the, we have 3 parts of this function, okay? Part 1, part 2, part 3. This right here is called the restricted domain. This portion here, off to the right. So y is equal to 5 from -5 to -2, basically. Have you guys met my Great Dane? She's right here. Oh, big dog, big dog. Say hi. Say hi to everybody. Her name's Lily, by the way.
Mr. Ainsworth, how many animals do you have?
A lot. Well, I have, right now we have 3 dogs. We have my Great Dane, who you just saw, Lily. We have the little Boston Terrier. Have you seen her yet? Okay, this is right here. Everybody take a look. This is my Boston Terrier. Her name's Jada. Everybody say hi, Jada. Okay. And then here's little Frenchie. He's our foster dog. Say hi to Romeo. That's Romeo right here. He's a pup. And we rescued him and we're bringing him back to health. He was in really, really bad shape and lost his fur, and now we're bringing him back to health. But he's only about 1.5, and he's our rescue. Yep, he's my buddy. And then I can't really show you Charlotte, our piggy. She's down below. And I can't show you Honky Tonk right now. He's our donkey, mini donkey. He's a miniature. He's down there. And then we have 2 horses, Denver and Nugget. And then we have our barn cat, Tango. He's outside. So just count them up. There's a bunch. Okay. All right. So here we go. Little Ainsworth trivia facts here today. So y is equal to 5. Okay, on this particular domain. So -5 less or equal to x, which is less than -2. Everybody go to the chat, please, real quick. Give me a quick response. What kind of function is this? You guys should know by going through all my 2 prep videos here.
It's a piecewise function.
Well, this whole thing's called a piecewise function, but what's this piece called?
The number 1,
Yep.
it's a constant.
Yep. It's a linear function, but more importantly, I like it now. Here we go. Constant linear horizontal function. Yes. Okay, let's write that down. It's called a constant function, and they are horizontal, and they happen to also be linear as well. So constant horizontal linear function. Well done. Very good. Okay, so here we go. This function is defined from -5 to -2, and it's up 5 units. So -5 is here on the graph on the x-axis and -2. So here's your domain right here. Okay, so we go up 5 units. You got to find 5 on the y-axis. So, and notice it's going to be closed here. It's going to be open here because you have to be strictly less than 2. So you have to know where it's open and where it's closed. So it's closed on the left, open on the right. Oops, open. All right, and it's a constant linear function. There's piece number 1. Okay, and you guys speak up if you have questions as we go. All right, I'm just setting the expectations of what I expect in the activity right here. Part number 2. Okay, now number 2, y is equal to -3x plus 2. So y is equal to -3x plus 2. And this is a linear function, obviously. And the domain is from -2 to 1. So we're going to set up a table of values. And given the domain, there's no guessing on the table. You start your table wherever the domain is defined. So the restricted domain is from -2 to 1. So you start in your table at -2 and you go to 1. So -1, 0, and 1. That's where you start. So there's no guessing on your X values. You look at the restricted domain and you start the table wherever the restricted domain is. So it's defined at -2. So we substitute in, so -3 times -2 plus 2. You guys can help me out evaluating. Show me, just go to the chat. What is that? Yep. Okay, I agree with that. 6 plus 2 is 8. And then you got to evaluate that -1. So what's -3 times -1 plus 2? There we go. Shane's rocking it. Okay, Berkeley. Shane and Berkeley. Okay. So 3 plus 2 is 5. And then, so just keep on going. Okay, you evaluate your function at these points. -3 plus 2 is -1. Okay, and then now let's pause right here. The first point in the table from -2, 8, is it going to be open or closed there? You need to know this. Open or closed at our first point? Okay, so if you look at the domain, it says -2 less than or equal to x. This portion right here, this inequality here means it's closed on the left. And if it's strictly less than 1, that means it's going to be open on the right. So it's closed here. On this one, it's going to be open here. Make sure you guys understand that. So we're going to go up here at 2, 8, closed. So -2, 8 is closed. And then -1, 5, 0, 2, 1, -1, open. And here's the second piece. So that's piece number 2. Closed on the left, open on the right. And you guys speak up if you have questions as you go, because like I said, I'm setting the expectations of the activity right here and showing you exactly what you guys should be doing in your activity when you get there. Now, the third piece is this square root function. So y is equal to the square root of x minus 1. And it's defined x greater than or equal to 1. So let's get some values here. So you start your table at 1 because the domain, it says all reals greater than or equal to 1. So you start your domain there. So 1, 2, 3, 4, and let's go up to 5. Okay, and then you evaluate your function. So it's square root of 1 minus 1. That's going to be the square root of 0, which is 0. The square root of 2 minus 1 is the square root of 1, which is just 1. And you just keep on evaluating. You guys can help me out with the next one, though. What's the square root of 3 minus 1? What do you guys remember about root 2 from prior activities? Give me an estimation to the nearest tenth. You constructed the root 2 on the number line. You guys know this. What's the square root of 2 to the nearest tenth? Very good. About 1.4. If you don't remember that, use Desmos. You type it in. Seriously. When in doubt, use Desmos and type it in. You'll be good to go. Okay, the next one. The square root of 4 minus 1, which is the square root of 3. I need a decimal for that too. What do you guys remember on that one? Because you constructed root 3 as well.
1.7.
Yep. And Maya agrees with you. Okay, so that's good there. So the last one we'll do is the square root of 5 minus 1, which is the square root of 4, which is just 2. Now let's plot these guys. So one is, oh, let's stop here actually. On our first point in the table, open or closed. Can you guys tell me that? Open or closed? Look at the domain. Whoa, not
Closed.
Okay, I agree with you. Okay, so we're gonna go close there. Because of the greater than or equal to sign, it implies that it's closed there. So let's plot here. And 1 comma 0 is going to be right here on the x-axis. And then 2 comma 1, 3 comma 1.4, 4 comma 1.7, and then 5 comma 2. It's a curve. This is part number 3. Now, how do we check this? Because you have the ability to check all your work. What do we use? That's correct, Maya. Okay, so let's go to Desmos now. So open up your Desmos account. You're going to be recording all of this in your activity, so everybody sign into Desmos like I am. Every time I open up Desmos now, I automatically get logged into my account, and I save all my work. And since I've already been through activity 7A3, I have all the functions in. See, look at this, see how fast? These are all the functions that I put in for the activity when I did it the first time. So when you go start this here, you go up to the top and you put a title in. So everybody put the title 7A3 activity. You're going to be submitting your Desmos work in addition to your handwritten work. So title it so you can save it, and saving your work throughout the unit or throughout the section 7, which is a huge section. We're going to be in section 7 for the rest of the year. It's that big. It's important that you guys keep a log of all your work in your account so that when we do a chapter test or a section test, when you start reviewing, you can go back into Desmos and you have all your previous work in there. And you can use it to review and to remember what you did, weeks prior. So you name it right there so you can save it, and then you start putting these functions in. Okay, so I'm going to just start from scratch though with you guys. So I just want to show you something or make sure you guys understand something. So I'm going to go from scratch as you guys are doing. So let's put the first piece in there, y equals 5. Go to your digital keyboard, type in y equals 5. Okay, now at this point, how do you put in your restrictions? What symbol on your keyboard do you use? What did you guys learn in the video when I was instructing on this? How do you put the restrictions in on your keyboard? It's on your keyboard. Just type it in the chat. What symbols do we use?
You use the curly bracket, which is besides the P and the
Yep.
backslash.
Right, and it's right above the square brackets. So you're gonna have to go shift. So use those curly brackets and you type it in. And here we go. So you type in a -5 less than or equal to x less than -2. So you just type it in and then return. And you'll see it appear right here. And your first piece. Now notice on Desmos here, I grabbed a point on Desmos. If you look at the screen, the left endpoint is -5, which is correct. It's closed. And look on the right, -2, undefined. It's open on the right, closed on the left. Desmos can verify everything you do and let you know whether it's correct or not. Okay. So we do it by hand first on paper, and then we verify it with Desmos afterwards. Let's go to the second line. Let's type in our next function, y equals -3x plus 2, curly brackets, and then type in your next restriction. So -2 less than or equal to x, and then less than 1, and then return. Oh,
You forgot to put the equal sign.
yes, sir. I just noticed that. Thank you. So notice on Desmos here, it's in blue now. If you put your cursor and click on the segment, go to the left endpoint at -2.8, which is correct. We got that in the table. Go to the right side. It's 1, undefined at 1, -1. So it's open on the right, closed on the left. So what's cool about Desmos is that it tells you where it should be open and closed. It gives you so much information. It's probably the best learning tool when it comes to graphing I've ever used in my entire career in 29 years. That's why I use it so much. I use it from algebra 1 all the way up and through calculus, okay? Because I teach all the different subjects. And then the last function, y equals square root, x minus 1. And then you have to go right arrow key to get out of the root. You got to go right arrow before you hit the curly brackets. And then you type in x greater than or equal to 1. And so when you look at your function here, there it is on the screen. There we go. Okay, so on the third piece in green, notice it starts at 1, 0 and it goes infinitely to the right because it's only defined from 1 to infinity, so it has to be to the right of 1. Okay, so there's the first one there. Let me pause here. Any questions on this before we transition? We'll do part 2 warm up later. This is what I expect you guys to do in the activity. You do it on paper first. You verify second. You don't do Desmos first and then copy. You do that, you won't be successful later on, okay? Because when I ask you to do a free response question, I expect you to do all the work by hand without a technology tool. The technology tool is only used to verify your thinking, to make sure you know you're good. Give me a thumbs up or down if you're good so far. Okay, let's do it. Let's transition. Let's go to activity 7A3. Okay. Dun, dun, dun. Okay, here it is. We're doing part 1 only right now. And I'm talking about parts A, B, C, and D. Okay, and you're going to stop there and submit. You're going to submit twice today. So part 1 or number 1 only parts A, B, C, and D. And we have 2 options here. I'm going to give you guys the option. Option 1 is to go into a breakout with your peers in a group of 6. Or option 2 would be to stay with me here in a group session with me and interact with me. So what do you guys prefer? Go to the chat and tell me, what do you prefer, option 1 or option 2? Breakout rooms, option 1, or stay with me, option 2. Okay, option 2 it is. Okay, so this is what we're gonna do. Go ahead and click save on Desmos because you're gonna be saving all your work here. Always click save after each one. And then deselect the ones you entered and then enter new ones in below it. Okay, again, you do Desmos last. Okay, get started on 7A3. I'm going to stay with you here. If you don't have enough room to set up your table, if there's not enough room in here to do your tables, then get out an extra piece of graph paper and do it on an extra piece. All right, but this is a 2-piece function. Y is equal to x plus 3 on the first function. You're going to need to set up a table of ordered pairs. And the second function is y equals negative x squared plus 3. And like I said, if there's not enough space in here, you can use the right margin or another piece of paper. Do whatever is best for you guys. This is going to take a while. When I did this with the last period, believe it or not, this portion of the activity took quite a while, and many questions were asked throughout the activity, especially when I got a student sample and we started analyzing it. So take your time here. If you have questions on evaluating the function, speak up immediately because I want to help you as you do it. Just turn on your mic and start talking to me. If I need to illustrate and annotate here and help you out with arithmetic, I'll be happy to do that, and I can do that easily. If you have questions on the technology, you can ask me that too. In last period, I had questions on everything: the arithmetic, the technology, how to interpret things. There were a lot of questions asked. So that's why I said last session was just an amazing session, because people actually were working very efficiently. They asked a lot of key questions, and then I interacted with the students quite a bit. So hopefully we'll do that here with you guys. So go ahead and get started, work at your own pace. When you're done with A, B, C, and D, I want you to take out your phone, scan and upload to Canvas. As soon as you're done with number 1, there are 4 parts. And and then I'm going to pull it from Canvas and analyze it and give you guys some feedback. And again, if you get stuck at any point in the problem here, you got to speak up immediately. Ask me questions because I want to guide you as you do it. We always do it on paper first. Desmos comes last.
Mr. Ainsworth.
Yep.
So I've got a question.
Bring it on.
Regarding the exponents and stuff, I know that whenever you have like 1 squared anything, it's still 1 because it's 1. But with 0, anything to the 0 power, it's also 1.
But we're
Correct?
not, the exponent is 2 and always 2 on this one. The variable, the base changes, but not the exponent.
Oh yeah, my bad.
So you're going to square whatever x value you put in the table. This function, are you working on the second piece?
Yeah.
Okay, so where'd you start your table in the second piece?
I understand now that the power doesn't change. That was
Yeah.
my folly.
Oh, that's okay. That's right. Just, again, it's okay. Speak up on anything. So Ali, Bella, and Matthew, would you guys send me a message telling me why your camera's not on right now? Oh, there you go, Bella. Matthew and Ali, will you guys let me know what's going on? I want to be able to see you guys every day. Thank you, Bella. No worries. Ask questions as you go, guys, especially if after you do it manually on paper and you go to Desmos and check it and it's not the same, you have to stop right there and talk to me. And, you know, ask questions as you go. Ali, thank you for messaging me. I understand. Just hang in there and just participate in the chat. Thank you, Matthew. There are no silly questions on this, guys. If there's anything that you're struggling with as you go through the activity, speak up immediately, and I will assist you all the way through. Oh, and I forgot part C, there's a typo. There's a couple things missing for some reason. So everybody pause for a second. There should be f of x, not x. It'll just be f of x. And the second piece needs to be fixed. Okay, I don't know how an explanation point came up there in exponent. This part is supposed to be x squared. So let's fix this. x squared. So the second piece, the first piece, y equals x plus 2. The second piece, y equals x squared. And then there's a third piece, y is equal to negative 2 times, your x minus 4. So everybody fix part C, please. Forgot to mention that in the beginning. Go at your own pace. Let me know if you need help on anything. And then once again, once you're done with all 4 of them, A, B, C, and D, I want you to scan it immediately to Canvas so I can give you guys some feedback. That last period was the important part, or the best part of the whole class period, was that when students started submitting work and I looked at it and I helped them correct their work, that was where the biggest learning part happened, right there. So we need to get to that part. So take your time, work on the first 4, and then submit your work. Make sure you fix part C. You guys show me on your fingers which one you're working on. We're working on 4 of them here, parts A, B, C, and D. Which one are you working on? First, second, or third, or fourth? Okay, keep going. Work at your own pace. I know I told you guys this is going to take a while. And again, if you have any questions throughout, don't hesitate to ask. Let me help you and guide you as you do it, especially if Desmos is different than what you have on your paper. Speak up ASAP. You do it manually first on paper, then you check it with Desmos. And remember, if it's linear, if the piece that you're working on is linear, then it's straight line segment. If it's quadratic, it's curved. If it's a root, it's curved, and you're going to see that in Desmos. And make sure you know which points are open and which points are closed. That's important too. And there's a couple of these are tricky. Like there's one tricky part in part B, and there's one tricky part in part D that you have to handle. So if you have questions on that, speak up. As soon as you're done with the A, B, C, and D, scan it, get it into Canvas, and then let me know when you've done that. I want to give you guys some feedback. You're going to be submitting this in on the page. It says 7A3 activity part 1 in Canvas. Maya, is everything okay?
Sorry, I got kicked out and I was trying to fix it for a while, but I finally got on.
Very good. I'm glad you made it back. Let me know when you're finished on A, B, C, and D, and after you get it up there in Canvas, I need to take a look. Alexis, did you try part D as well? Yeah. Yeah, it keeps on going, A, B, C, and D, and then keep on. So this looks good. I'll analyze this here in a minute. Do part D, and then resubmit part D, and I'll take a look at it when you're done. Is anybody working on part D? Do you guys know how to, and once you're done, you're going to check this in Desmos, of course, but do you know how to handle this part right here, entering the restriction? Let me know if you need help on that. Again, just everybody work at your own pace and do as much as you can here, and let me know when you're ready, and let me know if you have questions. And if you need help on the restrictions here on Desmos when you're ready, let me know.
Can you explain the restriction?
Okay, Maya. So So the function, the second part of the function, y is equal to negative x plus 3 or plus 3 is defined from 0 to 2, but not equal to 1. So what I had to do on this portion right here on the restricted domain is break up the interval from 0 to 2 into two intervals from 0 to 1 and then 1 to 2, because we're not going to go, the function is not defined at 1 because it says right here not equal to 1. So I broke it up into two restrictions: 0 less than or equal to x, less than 1, don't include the 1 there, and then use the comma, and then you go from 1 less than, not less than or equal to, just less than x, and then less than or equal to 2. So it's going to be open here and open here. And then on the left, it's going to be closed at 0, closed at 2, but it's going to be open at 1. There's going to be a hole in the function. Try that. Use it. Make sure you put a comma in between those two, though. Kind of like, let me see if I have it. Pretty sure I have this on. Yeah, let me pull this out. Okay, right here. Here we go. Maya, can you see that on the screen down there at the bottom?
Yeah.
Okay, so try that. You should be able to see the function. Like if I turn mine on, you'll see this graph right here, but you're going to notice something. You're not going to be able to see the whole. Uh-oh, what happened here? Hang on, here we go. But if you trace the function, watch what happens when you do this. You put your cursor on this, and on the left endpoint, it's closed at 0, 3. On the right side, it's closed at 2, 1. But if you put your cursor right at 1, it's going to say undefined. So you're going to have to put a hole there. So on your graph manually, because Desmos doesn't show the hole, it just shows it if you trace it. So if you're at 1, Desmos says, oh, it's undefined there because x can't be equal to 1. So you draw that line segment, but you put a hole exactly where it is at 1, 2. Does that make sense? Okay. So yeah, part of these, some of these parts are tricky, and that's where you guys got to speak up to me and let me know where you need your assistance on. And then after you're done with part D, scan it, get it up there in Canvas, and let me know. Alexis, did you hear that last part on part D when I was working with Maya right there? Okay, so after, because I know you're working on part D and you already submitted the parts A, B, and C. So I'll probably use yours, but I need to see your part D when you're done.
I know you just said it, but like, how'd you exclude 1 on part D?
Okay, so one more time, the function, the second piece, y equals negative x plus 3 is defined from 0 to 2. That's the first part of the interval there.
Mm-hmm.
But it says, and x can't be equal to 1. So you have to exclude it. So what I did is I broke up the interval from 0 to 2. Like suppose this is 0 and this is 1 and this is 2. I broke it up into two intervals. So from 0 to 1 open, and then union this interval here from 1 to 2. So the first interval is 0 less than or equal to x less than 1, and then use a comma. And then the second interval to the right of 1 is 1 less than x less than or equal to 2, and use a comma in between the two intervals.
Okay.
Does that make sense?
Yep.
Try that in Desmos and see if that works for you. Okay. Let me know when you scan your work in the canvas. I need to give you guys feedback.
Mr. Ainsworth,
Mm-hmm.
for the question D,
Mm-hmm.
where it says like negative x plus 3 if 0 and then that equation, and then x is not equal to 1. How would you graph that? Again,
Okay. So
would it just like would you just skip it
skip what?
like 1 since it's not equal to?
Well, actually, you would evaluate the function there, but because it's not equal to 1, you'd have to, there is a hole in the graph. So when if I was going to do this by hand, right here, I'd set up a table.
Mhm.
So let's do it together here. This is piece number 2. Okay. So the first interval, it says 0 less than or equal to x less than or equal to 2. So the interval goes from 0 to 2, but there's going to be a hole at 1 because the function is not defined there. But we're still going to evaluate it there because we need to know where the hole is. There's going to be a hole. So I'd start at the table at 0 and I go 0. This is a linear function, okay? So it's going to be a linear function with a hole in it. So 0, 1, and 2. And I'd evaluate this function at those 3 points, but at the whatever 1 comma the point is, there's going to be a hole there. So what'd you get in your table when you did that? When you evaluate negative 0 plus 3, what do you get?
I'm thinking you get -3 or just 3.
Yeah, negative 0 is just 0. And 0 plus 3 is just 3, right?
Yeah,
And then you get negative 1 plus 3. What would that give you?
that would give you 2.
That's where the hole is. So label this hole. This is a hole because the function's not defined there.
Okay.
So you're going to go open circle there. Okay, and then what'd you get for when you evaluated at 2? You got negative 2 plus 3. What'd you get?
1.
Okay, so you plot those points. So let's plot 0 comma 3, and that's going to be closed there. And then you're going to plot. You're going to go open at 2, 1 comma 2, and then closed at 2 comma 1. So it's going to be a linear function, but there's going to be a hole in it.
Okay, thank you.
Okay. And then on Desmos, you have to break it up into 2 intervals when you put it in, as I was explaining earlier with Maya and Tristan, okay? Well, Alexis, yeah, don't do part 2 yet. We'll just go ahead and submit A, B, C, and D. You submitted A, B, and C. So just take a picture of part D and throw it in there. And I'll take a look at your work here in a minute when you're ready.
Hey, Mr. Ainsworth.
Yeah.
I'm on part D, and I put the graph of where y equals 0, and like my graph's not popping up. Like,
Are you talking about in Desmos?
yes, like to see.
I know. Okay. So, okay. Now it says, I'm glad you brought that up. And there's a reason why you can't see it. Okay. So let me expand this a little bit. So it says y equals 0 if x equals 1. So y equals 0 if x equals 1. Okay. You know what that, everybody take a look at the screen on this. The third piece of the function, y equals 0 if x equals 1. What does that look like on the graph? What is that?
Is it a straight line on like the 0 axis, the y, not y, x axis?
It's actually more simple than that.
Isn't it just a point?
Yeah, is it just a dot?
Okay. Alexa, say it again.
Jalen and I said it's just a dot, right?
Yeah, it's a point. What are the coordinates of the point?
0 and 1.
That's right. Well, be careful. Which comes first, x or y?
X, so 1 and 0.
Yeah, 1 comma 0. So it's not a line, guys. It's a point. So Jalen, that's why you can't see it on the graph. So when, like right here, I have it. It's look at my Desmos here. Let me expand it. So purple. Can you see my on the lower left-hand corner of the screen the equations? When y equals 0, y equals 0 when x is 1. That's a point at 1 comma 0. And Desmos, when you're graphing functions like this, it doesn't have the ability to show it, you know, a big dot right there, because it's not a line. It's a dot. It's a point. Do you follow me now? Okay, Berkeley, are you good with that? It's actually a point, and that's why you're not seeing a line, because it's not a line. It's a point. It's actually right here at you know, on the x-axis at 1 comma 0. Okay, and it's stuff like that that you guys got to get used to when you deal with these crazy piecewise functions. It's like, when is it a line? When it is a point? When is it a curve? Okay, there's a lot to learn. Okay, Alexis, let me pull yours up and let's analyze yours, and let me give you some feedback. Okay, and what I want you to do as we do this is I just want you to correct your work if you need to. If anything is needed to be corrected, then do it in red. And then if you make any corrections, or if you need any corrections, you can always resubmit it into Canvas. It's not a problem. But I need to pull up your work. So let me do that. And this is the important part about doing homework, is you need to get feedback. So I'm going to choose Alexis just because she's ready, and I'm going to take a look at it. So let me download her work. And I'm going to use Alexis's work to start the discussion. And I want everybody to get involved in the discussion and grade your own work. But I'll use Alexis's work as the discussion piece. Give me a second. It takes me a second here to, oh, come on, to get it into my program here. So give me a second. All right, Alexis, you ready? Okay, everybody ready? Okay, so this is where I want everybody to look and listen to the feedback that I'm going to give her. And I want everybody to correct your work at the same time. So pause wherever you are, pause, and let's analyze her work. And like I said, if don't worry about making any mistakes. This is part of the learning process. Okay, just it's looking good, by the way, too. So the no. Let me see, where am I at? So just ask questions as we go. I'm going to detail it out. And like I said, if you need to make any corrections, no big deal. This is part of the experience. In fact, it's the most important part. Okay, so piece number 1 is here. So look on the left side here. I'm looking at her domain. Everybody pause what you're doing and look at her work. And I'm noticing that it's closed at -1, 2, which is good. Her tables look good, and it's to the lower left. So this part looks good. On the right, piece number 2, it's a parabola. It's a curve. It's called a parabola. Everybody write that word down. And parabolas are curves. And so it's not a line here. And notice that she doesn't have a line. She curved it. And you can see that by looking at the graph. So let me pull up the graphs at the same time. So I have these functions already put in. Okay, so here we go. Dun, dun, dun. Okay, so notice, okay, there we go. Okay, so she has a portion of the curve. Notice it's a curve, and I don't have my, let me see what happened here. Okay, there we go. And then, so part number 2, this downward parabola here, it continues. X is greater than 1, so this part here continues as well to the lower right. So I like your number 1. It looks good. Looks very accurate. And you guys, as we do this, grade your own work, correct your own work, and more importantly, ask questions if you're making any mistakes or if you're not sure about something. Okay, her number 2 has 3 pieces. So piece 1, 2, and 3. So piece 1 is here, and this is the critical piece. Now notice, everybody look at her table. She started at -3. Check your table. Everybody check your table. Did you start at -3? Not at -2, but at -3. Because if you didn't, you need to. And there is a reason for that. Alexis, what do you mean by that?
It's just embarrassing, and I don't know why, but it's embarrassing. It's fine.
Well, it shouldn't be embarrassing. You're lucky that I actually picked you because you're the one that's getting the feedback. You're actually the lucky one out of the group. And it should be embarrassing because you do good work. Okay, so you're all good. So don't be embarrassed at all. So you start the table at -3 here because the domain of the function of a root function, the domain. Let's talk about that here, guys. Everybody look at that function, the square root of x plus 3. What is the domain? Everybody pause for a second. Everybody take a look at that. What's the domain of the root function? That question goes out to everybody, not Alexis. What's the domain of the square root of x plus 3?
The domain would be anything less than and equal to 2.
Why is that?
Because you see, if x is less than or equal to -2, so that means anything that is less than or equal to -2.
Like -5 is less than -2, but is that function defined at -5?
No.
Why
Oh
not?
yeah, because you can't, when you're square rooting, you can't have like a full negative. So it could be -3 or -2.
Okay, so what's the domain really? Because the restricted domain is, yeah, it says x is less than or equal to -2, but really what's the domain of the root function? That's what I'm asking everybody here.
Oh, that would be x is greater than or equal to -3 and less than or equal to -2.
That's exactly correct. Did everybody understand that? Let's dig a little deeper here. On the domain here, x plus 3, whatever it has to be, it can't be negative. So it's got to be greater than or equal to 0. And because of that, if you subtract 3, and you'll see that the domain, the actual domain, is from all real numbers greater than or equal to -3. So I was really happy to see that Alexis put -3 in the table, because you need to evaluate the function at -3 and then stop at -2, because as Shane just put out, the restricted domain is, the numbers less than or equal to -2, but they have to be greater than or equal to -3, because you can't square root a negative. All right, so this is a good looking table right here, and she evaluated the table and got the first part of the curve. Okay, from -3 to -2. This is the domain of the first function. So I like that. Second piece, y equals 2, that's constant. And it's open on the left, closed on the right. So piece number 2 looks good. And then it's going to be open at 1, 1 to the right. And so the third piece looks good. So all aspects look good on part B right there. So Alexis, you're doing really well. And then part C, we've got 3 parts. So part 1 is this linear function, y equals x plus 2. Part 2 is x squared. It's a parabola. So this is piece number 2. And part 3 is linear. And it's actually perfect. But you guys have to make sure you understand that. But this one is perfect. All 3 parts. You guys need to jump in if you're not getting this, or you're not fully understand this. This is where you guys have to ask key questions. Okay, because I'm just giving her some feedback, and then you're supposed to be looking at your work, judging it on what you're seeing up here on the screen. It's looking really good. And then part D. So this has 4 pieces. See, so part 1, part 2, part 3, part 4. So part 1, y equals e. And so y is equal to e, which is approximately equal to, she said 2.718. So here's part 1. So it's open. Let me see. Okay, this is almost perfect. We have to modify just a little part of this. So you see the domain, it says x less than 0. So Alexis, what we need to do is 0 is here on the x-axis. So it's only defined to the left of 0. So we need to start it here. So fix that little portion. Does that make sense to you? Okay. This is the learning part. That's the critical part. And when you hear critique from anybody, it doesn't matter who it is, it's meant to help you. So you guys should not be embarrassed at all on anything when I critique your work. You're supposed to learn from it. And if you learn from it, that's the important thing. Okay. That's the only important thing. So part 1 there, just modify it slightly. Part 2, -x plus 3. And it's defined, so it's closed here. That's correct. We got a hole there at 1, 2. That's good. And then closed here, that looks good. So part 2 is good. And then part 3 is linear. And it's, here's part 3 on the right. Open, open on both sides. I agree with that too. Very well done, Alexis. Very well done. Any questions, you guys? Got to be honest with yourself and me. You got to compare your work and make sure you understand it. Not slightly. You want to understand it fully. Try to always strive for a deep understanding. Talk to me, my friends. Any questions on A, B, C, or D?
None from me.
Thank you, Shane. Thank you, Berkeley. Thank you, Marianne. Okay. Okay. You guys sure you don't have any questions on parts A, B, C, or D? Okay. Thank you, Ali. Then let's do this. I don't have enough time to do the second part with you. So you guys are going to be doing that part on your own today. You're going to finish it up on your own. So let me go back to the part. So part 2 is the reverse process. I give you the graphs and you have to come up with the functions. And when you come up with the function, the piecewise function here on this, there's 2 parts on this one. And so you're going to have to describe what the function is and the restricted domain of the first part and the second part. On part B, there's 1, 2, 3 parts of the function. So when you describe this one, there's going to be 3 parts. If you have not gone through the video of second prep video, I wouldn't even do this until you do that. Okay. I've already graded the second prep and taken a look at work, and only half the seniors have submitted their work, which means there's half of you guys that haven't even gone through my second prep. So don't even attempt this unless you do that. Once you do the prep video, then you do this and you submit part 2. All right, so let's go to Canvas here and let's see where the resource is. Okay, so this is where you submit part 1. I expect everybody to do that before the class ends. Okay, so this is due by the end of class right here because we finished it. We talked about it. So all you have to do is scan it and put it in there. If you click on the next page, like I said, half of you guys submitted your work on prep 2, and I'm proud of you guys. You guys are up to speed. You guys are ready for the second half. If you have not done this, then you need to do it because you need to develop the skills ready for the part 2. And then sometime today, you can work on the second half of the activity here and submit it here. Okay, and then you're good for 7A3, and you'll be complete. Over the weekend, if you finish this today, there'll be no further work over the weekend. The only thing I need to tell you is that on Monday, and you should write this down on your calendar. So get your calendars right now and write this down. And on Monday, you'll have your quiz on 7A1, 7A2, and 7A3. And I'm going to publish it early in the morning, and you'll have all day to do it. So write it down. Quiz on Monday, 7A1, 7A2, and 7A3. And all your work on those activities has to be done by Monday. I won't accept any late work after Monday. Your work has to be done before the quiz. So you have to get caught up. So I give you the weekend to do that. And then if you get all caught up on all your 7A work, 7A1, 7A2, 7A3, then you'll be ready for your quiz on Monday. And then of course, we'll do something on Wednesday next time I see you. Any questions or needs before I let you guys go? Okay, so well done today. You guys have a super weekend. All right, get some rest, get caught up, make yourself proud, and I'll see you guys soon. Okay, you guys take care. Good job today. All right, and I'll see you guys soon. Well done.
Have a good one, Miss Ainsworth.
Thank you, thank you, thank you. You guys too. I'll see you guys soon. Tristan, I'll look at your email later when I end our session here together, and then I'll respond via email to whatever you're.
Do I mind showing? Okay, so do you mind me briefly talking about it?
No problem. Do you want to
Okay.
do this privately or do you want to?
No, it's right here is okay. I don't mind.
Okay.
So essentially, um, as you probably know, you can see when we all submit and stuff, and you probably know that I like to submit mine pretty close. I make some pretty close calls a few minutes before, which I should be better at. But anyway, so I was about to submit, and my Desmos started acting up. And it happened before. I wasn't able to screenshot a picture of it before, but I I could show you now if you want to. But
Well, just go ahead and finish what you were saying, and then I'll.
either way, Desmos started acting up. I even tried to refresh it and stuff, and it didn't work. So I shut down my computer and stuff because Desmos had crashed, and then like the graphs didn't save, so I needed to like remake all the graphs and stuff. And because simply you couldn't do the prep work without Desmos, there's like no way. But but anyway, so I had to remake all the graphs because it would be impossible to show my work without it. And anyway, so it took a lot longer. And yeah,
So
it
but
was
what
a
do you
little
need?
late.
What,
Because
what do you need from me?
well, I don't know.
Then what can I help you with, Tristan?
Could you forgive it because Desmos crashed?
Which one are you talking about? Which activity?
The 7A3 prep activities. I submitted them together at about the same time. But then I
Okay.
also tried to write you a note, but I had to resubmit that to do the note. So it shows as like being like really late.
Okay, so 7A3 prep 1 and prep 2, you had difficulty submitting your Desmos work because it crashed and all that.
Yeah.
Okay, I'll go back in there and look at it, and I understand that happens sometimes, and I'll just take a look at your work, and I won't worry about the Desmos thing because I understand things happen.
All right.
But
Thank you very
I won't
much.
deduct any points on those two preps based upon what you said. I'll be lenient on that, no problem.
Thank you so much.
Yeah. So
I'll go
on
ahead and
Desmos,
finish the 7A3, right?
yeah, do that now. And so what I suggest on this crazy activity, see how many functions I have in this lesson right here?
Yeah.
So make sure you hit the save button frequently, like after each one, hit the save button. Because if stuff happens, like if your computer crashes, which happens to me sometimes too. Like in our class, I think it's my screen is frozen and then I get kicked out. I have to restart my computer and I send you guys a message saying, hey, I'll be right back, right? And then if I didn't save all my work on a frequent basis, then I too would have to redo all my work.
Mhm.
So I always click that save button like multiple times after I do or finish each part of the activity one by one.
Mhm.
So, but don't worry about what you just said. It's all good.
Okay. Now the other assignments, I don't remember doing the Desmos as much for them because I felt like you could do them without the Desmos, like the 782 and 781 and stuff like that. Um, should I have to do the Desmos? Because I'll just go in and do it.
Did I make comments to you in when I graded your activities?
Let me see.
When an activity is when I go through an activity or a prep or something that really requires it, and then I say, submit your Desmos work as well. If it's really critical, then I don't give full credit for those students that don't submit their Desmos work. I give maybe either a 7 or 8 out of 10.
Yeah.
If it's not super required, then I'm a little bit more lenient. It all depends on the activity and what I see.
Yeah, you
Um,
didn't post anything, so I'm good. Thank you. Thank you very much. And I could show you a picture because it happened before, and I took a picture of it and showed it to my friends because I thought it was kind of funny. Um,
no, I believe you. We're good.
but yeah. All right. Thank you
Okay.
so much. Have a great weekend. Um, See ya.
All right. Take care, buddy. Thank you for bringing all that up. All right. Maya.
Yeah, I was just gonna ask, so for B on the second part, I already finished all of it. I just want to make sure the signs and everything are correct. So if it's like if it looks like a circle, does that mean it's opened or are the darker ones closed? For on like,
Okay. I think I understood what you said. You're very faint. I can barely hear you. Hang on. You were talking about part D. Let me just increase my volume here a little bit.
is this better?
So ask your question on part D again one more time, because it's hard to hear you.
Oh no, for the second part, for the writing the equations and all that.
Oh, okay. So on part D on this one here, what was your question on this one?
Well, I just want to make sure that, so for the one that's farthest to the right that looks like a straight line, is that considered a closed circle? And then like the other ones are considered open, or are those all open circles?
Yeah, it's kind of hard to tell. I think based on what I see right here, I think that this one is open. This one is closed. This one's open. And this one's closed. That's what I'm seeing. Do you agree or disagree with that?
That's what I thought, but then when I looked at B, I noticed that there are no circles, so I was really confused on what signs to use there.
Well, let's just assume that this right here is closed at 2, 2, and it goes infinitely to the right. It hits the end of the window frame here, so it continues to the right. And this part number 1 hits the end of the window frame, so it's going to continue to the upper left. And this right here is a semicircle.
Mm-hmm. So and then for
say it
letter
again.
B, for letter B that's above that one,
Go ahead.
I don't see any circles, so what should I do for that one?
Oh, well, these are all linear parts. So these are all linear. So you're going to have to find the slope and the Y-intercept.
Mm-hmm.
Have you gone through the second prep yet?
Yeah, I'm done with all of it.
Oh, wow. Okay. So what I would do is I would say, like, let me label some letters up here. So at point A, and let's call this one point B just for discussion purposes. If you want to find the slope, you got to do a little rise and run action. So to get from A to B, you got to go down 3, right 3. So what do you see for the slope?
It's just being -1 or
Right.
-x.
Right. So it's going to be y is equal to -x plus something. What's the Y-intercept there?
0.
Right. So it's just y equals -x for this first piece. And then what are the restrictions on the domain?
That's where my question comes in, because I don't know if it's going to be a closed or an open circle. So I know that it's about, it looks like it's going infinitely to the left. So it's going to
Yes.
be x less than or equal to 1.
Correct.
Okay.
You're totally correct. Yeah.
Okay.
And then the middle, they're all linear functions. So do the same thing, find the slope and the Y-intercept of all 3 pieces, and then just use your intuition on your domain like you were doing in the first part. You're on the right track.
Cool. Thank you.
You're welcome. Have a good weekend.
You too.
Okay. Aiden, how can I help you, sir?
So I'm pretty much caught up on all of my assignments now, which is Good. Can I still retake the second part of the test?
Mhm.
Like, is that still available?
Yeah, I'll give that to you. And the, excuse me. Remember what I said? We have to like meet at school.
Yeah.
We can do that on Monday. We can do that on Monday.
Okay. Yeah, cool. I just wanted to check up on that.
Yeah, let me figure out what time I can get over there because I have, on Mondays we have to check in with our home period at 8:00. So obviously I have to log in there with my third period. And then I have a staff meeting and a couple meetings in the morning, but I think I can be there around noonish, but let me confirm that. So write it down on get a calendar, a piece of paper, and write down Monday at Great Oak High School, noon with Ainsworth. But I need to confirm that. I'll get a hold of you over the weekend to confirm that. And then you know where the front office is, right in the main office. You just go straight in. You can access the receptionist right there. That's where I'll meet you, right there in the front office in the main door.
Okay, cool.
And then, but again, I'll get a hold of you through Remind. I'll send you a message and confirm noontime.
All right. Thank
Sound
you, Mr.
good?
Ainsworth.
You're welcome,
Yeah.
Aiden. Have a good day,
Have a
buddy.
good weekend.
You too.